Hello students, welcome to the Old Time Biometry Show. Today I want to show you how to do a two-sample t-test or an independent sample t-test. And what we have here is two genotypes, HW and CA, and there's a whole bunch of cultures here. And from each culture we measure the mass-specific chlorophyll content. And so now we can go and study this a little bit. So we go up here and maybe take a graph. I like this legacy dialogues graph here. And we can go and show the means plus or minus the error bars. So error bar, simple error bars, that's good. Define. And then the variable is chlorophyll content, that's our dependent variable. Genotype is our x-axis. And then we want to show standard errors of the mean, and we only want one standard error of the mean up and down, not two. Two would be very close to a confidence limit. So then I think that's okay. You click OK, and it makes a nice little graph there that you look at. You can see that there's not very much space in between here. So, like maybe it's significant, but maybe not. So now we would go off and do the two-sample t-test or independent sample t-test. We go to Analyze, and then Compare Means, and maybe Independent Samples t-test like that. Chlorophyll content is our test variable. Grouping variable is genotype. And then it says define the groups, and it just wants you to put in here HW and CA, and it has to be capitalized exactly the same way as it is in the data sheet. Click continue like that, and OK, and then it gives you the t-test. So you can ignore F for the minute. Here's T, and there's two different t-tests. So one assumes equal variances, that's the standard t-test, and it has 53 degrees of freedom. And then there's one that assumes unequal variance, and it has this odd number of degrees of freedom here. So you could copy this over, and you choose one or the other, but not both, and report one of those. Good night, and good luck.